Hello there, thanks for tuning to my channel and welcome to my live stream. If you are new here, welcome. If you're an existing subscriber, also welcome back to the channel. So my name is Abatan Sheriffdeen, but you can call me Sheriff for short. I'm from Nigeria, I'm in Nigeria, and I'm live streaming for the next 100 days, doing what I love, learning to become a full-time data analyst. Currently, I'm a full-time freelancer. I generally work from home every day since 2020. I became a full-time freelancer this 2023, and it has been an amazing journey for me. So recently, I decided to upskill and learn some new stuff in my niche, in my industry. So I'm currently learning the the SQL track on Datacamp. I'm currently subscribed to a 1 year subscription on Datacamp, and I've been doing this consistently for the past 32 days. If I take a couple of lessons today on the platform, I will achieve 33-day learning streak. And the idea behind this is that I want to be consistent with the learning journey. I don't want to learn for a couple of days and relax. And the idea is to make that is possible and to achieve that and be consistent with it is to learn as little as possible every day. I'm going to spend hours on a day on hours a day trying to finish the course or consume all the knowledge from the course because these are technical stuff and you don't want to be rushing it and just jam packing yourself with knowledge to the extent that you become overwhelmed and can't even remember what you've learned. So the idea is to like learn 30 minutes, minimum of 30 minutes, maximum of 1 hour every day. And I've been able to achieve that and gain a lot of knowledge using this technique. So if you want to learn anything, especially technical skills or in the in the tech industry, I would advise you start learning for 30 minutes or even 15 minutes every day to build that learning habit. Then you can start increasing the number of hours as you move on. So today is day 33. So welcome to my live stream. So I've been a freelancer for the past 2, 3, 4 years. You get it now. And I have someone who has been teaching me and walking me through the ropes of freelancing, what to do and what not to do. So his name is Denga DBE, and he currently has a course called the Freelance Client Magnet course, which teaches you how to become a successful freelancer and become a top 1% freelancer in the world and have a successful freelancing business. He's a highly rated freelance coach. So I'll leave a link to his Twitter account so you can check out his profile on Twitter or on X. You can check out his profile on X. You are still used to calling it Twitter. You can check out his X profile. And you see a lot of testimonials from his students. And if you are if you are convinced enough and you really need someone to walk you through freelancing, to guide you through the ropes of freelancing, you can come back under the YouTube description. I have a link to his course that gives you 10% off your first purchase of his course. And if you purchase the course, it's a lifetime. You have a lifetime access to the course. You also have a lifetime access to him, which it gives you support every weekend, a Zoom support where he tells you what to do, what you are doing right, what you are not doing right, what to do, what not to do. And you have a one-on-one conversation with him. He guides you through to the end till you achieve your freelancing goal, to become a successful freelancer, and you can stand on your own. Even after you start earning money and you are on your own running a freelancing business, you still have access to him as a student and as a coach is really, really ready to work you through it. So don't forget to check out that course under the YouTube description. So let's get back to today lessons. So basically, before I start my new lessons today on the Datacamp platform, I always have to review one or two lessons. So on day 32, today is day 32, you get it now. So if I complete a couple of lessons today, we'll continue from where I stopped yesterday. I always have to review a couple of weak areas. So we found some weak areas for you to review and practice. So I'll just click that and review that real quick for the next 50, depending on how hard or how intense it is. I'll just leave it for like, it takes me like sometimes 10, 15, 20 minutes to review these areas, this week areas. And I kind of love it because I have the opportunity to practice what I've the past knowledge that I've the past courses that I've taken on the platform, which really, really makes sense to me. So I'm waiting for that to load. So for each station, so this section is on correlated queries, nested queries, and common table expression in SQL, popularly known as CTE. So for each station, what's the difference between the number of rides started at the station and the number of rides that ended at the station? So what is the difference? We need to count that like a minusing. Then number of rides started, the start station, you are counting the number of rides that started at the count station, Then we count the start station also minus number of rides at the end station. So that's the trip difference. So we are referencing the same table twice. So we can just say from trip as where the start station equals to the end station. That's the reference where this is as T. So the start station table as the alias as T, while the end station table as the alias as T1. So I need to reference the T dot start station here and also group it by the start station here. So we get the difference. I'll just group it by the start station. Check that. Correct. So what type of queries can be placed inside the common table expression? All of the above. You can place queries in the where, subqueries in select, subqueries in from. You can place all of the above in a city. So how many columns in the outer query were referenced in the correlated subqueries? Okay, player name. They're asking that how many columns in the outer query. This outer query. In the outer query were referenced. Okay, how many columns in the outer query were referenced in the correlated subquery? Okay, we're having player name here, the preferred folds, the potential of the player from players as P, where penalties is greater than average penalty. They're not calculating average here. Average, so this is wrong. Let's check out this one. This is a whole lot. Where so much where and so much filtering here. So there's no, I can't see any filtering criteria here. So I'll just go for this second option. It's quite straightforward. Where penalties is greater than one. Oh, that's correct. So in a table of soccer matches, which matches have a total number of goals scored more than three times the average? Can you determine this using a correlative subquery? Three times. When you get three times, that means we need to create a table of soccer matches. Which matches have a total number of goals scored more than, so we need to calculate three times. We need to calculate the average and multiply it by three. So in the subquery, look at it. Select average home goal and away goal times three. So we now select the goals that are greater than the average goal calculated here. Okay, you can see where this one here, hold up, was our linking table. Our M table is this outer query here, where M dot, once you can use the country ID as our matching column there. M1 is this table here. So definitely that's what we use as our matching query. Country ID. So, so the most popular station to start a trip, also the most popular station to end a trip. Can you set up and join two cities to get this result? If you want to set up two cities that shows the most popular stations to start a trip and also the most popular stations to end a trip, then you can just select our result with this outer query here. I'll just say with S as this is the first city, select start station, count the number of trips in the start station let's see, then go by the start station. So select end station. So this end station you can say E as. So select the end station, count the number of trips at the end station as end. From trip, go by end station. So we now use this result of the start station city, then the end station city in this our outer query here. So I'm going to select start station, end of start station. I'm selecting the start station from this S table, this temporary table. So when you create a common table expression, you are storing the result as a temporary table which you can use to query. You can use another query to get result from that temporary table. I hope that makes sense. Then s.st as stats. So s.st, we're setting this s the count, okay. N.s as end, e.end, okay. Also the end there, e.end as end. You can see from s. So now I join start station from s inner join. So that will be inner join the s table to the e table. Now that will be e.end station. So we have to be careful there. So we can check that, or we are good to go. Now we just review that real quick. So data theory. Oh, let's go. So we are going after day 100. Or is it day 100 or day 100? The 100th day. So now let me do a couple of lessons today and add to the knowledge. So it helps the knowledge to compound over time. So I'll just continue. So I think I've completed 2 chapters under this course. Or let me just show you what the course looks like. The actual course track rather. I'll go back real quick. Let me go back real quick. So if I go to the course tracks here, if I go under career tracks, you can see what it looks like. So that is coming up. So you can see they have various career tracks here. So I'm actually studying the data analysis and SQL career tracks. So under the career tracks, there are a couple of courses there. If I click that, let me click that. That's coming up. So you can see I've completed a couple of courses under the career track. So it's quite a lot, but before you know it, we've covered everything. So I'm currently under this section called Postgres Summary Start and Windows Function. So I've completed 2 chapters there, remaining 2 more chapters. So the other courses also, you can see. So at the end of the day, there's a project. So that is because after I finish this, then I move to another track, another career track, probably Power BI or Excel. But I plan to study Python last. I'm planning to improve my Power BI skill and Excel skill also. I need to improve on my Power BI and Excel skill also. So let's continue today. Before I start, I always love to download the slides so I can follow along. Yeah, if I click on show slides, I have the option to download it right here. So these are the slides. I can just download it right there. It's downloaded. Let me open it in my folder. So I have the slide up already. So let's get started and learn something new today.
Welcome back. In Chapter 2, you learned about new window functions to fetch, rank, and page rows. In Chapter 3, you'll use the aggregate functions you already know in a new context. Let's set up the source table first. This query returns the count of gold medals Brazil has earned in these 5 sets of Olympic Games. After wrapping the previous query in a CTE, represented query in after first.
So here count of medals from summer medals where country is Brazil and the medal they won is gold medal from the year 1992 upward. So this query is returning the count of number of gold medals Brazil has won each year they'll be participating in the Olympic Games.
This query returns the count of gold medals Brazil has earned in these 5 sets of Olympic Games. After wrapping the previous query in a CTE, represented by the 3 points,
So with Brazil medals as they select the maximum medals, maximum medal from Brazil medals, then select some medals, okay, total medals, okay.
using the max and sum aggregate functions on the medals column returns the highest medals earned in a year, 18, and the total sum of medals earned across those years, 64, respectively. These are the standard aggregate functions that you can use either over the entire table or with group by. What if you want to see the maximum medals earned so far, or calculate the cumulative sum of medals earned? You can use both max and sum, as well as other aggregate window functions, count, min, and average, as window functions. In this case, using max on the medals column and defining a window ordered by year in ascending order will show that
So this one is showing with Brazil as medals, select here medals, the maximum medals, here was over, use the over clause, ordered by year assembly, and max medals. So it is showing the maximum medals, hold up, 13, 2004, 2008, okay.
the max medals earned so far for each row. For example, in
For each row, that 92 is 13. This 996 should be 5. Why is it showing?
1992, Brazil earned 13 medals. Since it's the first row, that's the max so far of medals earned. In the next set of games, those of 1996, only 5 medals were earned, so the max is still 13.
Okay, hold up. So if you're looking at it by year, for 1992, the maximum medals is 13. For 1996, it is 5. So you see, it that the maximum medals earned so far is 13. Is that what it's telling us? But for 2004, the maximum medal is 18, which is higher than 13. So it's going to return 18 here. For 2009, it's 14, which is lesser than the maximum of previous years. So it's going to return. But let me use the explanation first.
Max so far of medals earned. In the next set of games, those of 1996, only 5 medals were earned, so the max is still 13. In 2004, the games after the 1996 games, 18 medals were earned, which is higher than the previous max of 13, so the max becomes 18. In the next 2 subsequent games, 14 medals were earned, which is less than 18, so the max remains 18 to the end of the query.
Okay.
Sum can also be used as a window function. With the same window that was defined for max used for sum calculates the cumulative sum, or running total, of the medals earned so far.
Yeah, I know that some we're going to play the running total of medals, which is quite easy to understand, but that max is kind of funny though. Okay.
The first cumulative sum is 13 because there's no previous value to sum up. The second is 18, the sum of the medals earned in 1992, 13, and 1996, 5.
That's 18. Okay.
Just like any other 5. The sum of the medals earned in
Let's add in cumulative frequency. So 18 plus 5 plus 13 give us this. 14 plus 18 plus 5 plus 13 give us this.
1992, 13, and 1996, 5. Just like any other window function, you can partition with aggregate functions. The source table is expanded to include a country column and Cuba's earned medals. In the left table, sum is used without partitioning by country, so the cumulative sum does not reset per country.
The cumulative sum, we said by 15, 14 plus 18, that's 32. 14 plus 14, that is 28, plus 18, that will be 46. So if you partition it by country, so if you're adding for only Brazil, let's start again for Cuba.
The value in the last row, 84, reflects the total medals earned for both Brazil and Cuba. In the right table, sum is used with partitioning by country, so the cumulative sum resets once the country changes. The last row's value, 46, reflects only the total medals earned by Cuba, while the last row for Brazil represents its own total medals earned, 46. Now that you know how to use aggregate functions in a new context, practice using them in the following exercises.
So let's practice some functions. So the only total or cumulative sum of a column helps you to determine what each row's contribution is to the total sum. So return the outlet, number of medals they earn, and the medals running total, ordered by the outlet names in alphabetical order, ordered by outlet. So we have a city here, which is going to return the outlet, number of medals they've won. Okay, let's run this city first. So we have the athletes, the number of medals the athletes have won so far. The athletes was actually they are from the country USA, and the medal we're looking at is the gold medal from the year 2000 upward. So from here, I can select the athlete. So let's calculate the running total of athlete medals. So I can select the athlete from here. Control C. I can just read the results. Then number of medals they earned. I can say medals they earned like this. Then the running total. That will be sum medals. I'll be summing the medals. Sum the medals over ahead and the medals running total ordered by athletes names. Dot ordered by athletes descending in alphabetical order. Okay. Order it by athletes from ordered by athletes ascending from athlete medals. And let's run this and boom in alphabetical order. You can see it's in alphabetical order. Ascending by athletes. Okay, let's submit that. That should be correct. And we got the full mark here. So getting the maximum of a country's earned medals so far helps you determine whether a country has broken its medals record by comparing the current year's earned medals and the maximum so far. Sorry about that. So return the year, return the year, country, medal, and the maximum medals earned so far for each country, ordered by year in ascending order. So return the year, country, and the maximum medals, this number of medals. So we use a city to count to return the country, and the number of medals that country have won. But where country in, so we are returning for China, Korea, and Japan for each year, 2000, China, Japan, Korea, 2004, China, Japan, Korea, and 2008, then 2012. So we are returning for from 2000 upwards. Now I want to return the year, the year, this year, city. I just copy that just to make you understand how city works. Return the country also. So we want to return the country from here. Then the maximum medals n. You can see maximum medals. Mm, I still want to return the medals so I can compare that with the maximum medals. Can see medals also. Then the maximum medals that end. Can just bring in marks there. Maximum medals over the partition it by and so far for its partition by country, order by year, order it by year, so it's going to differentiate it for each year. So if I run this query now, it will return each year's medal for each country. It will return each maximum medals for each country and compare it with them. But I don't want to submit yet. But let's see. Now when you look at China for 2000, 2004, 2008, the medal they won in 2000 is 39. So the maximum will be 39. Then if you compare the previous year, the current year medals won to the previous year, which is higher than the previous year, it is 152. Then same thing for 2008, 74. Then 74. You get it. But when you look at this one here, for like China, okay, now you can see for 2012, the current year 2012 is less than the previous year. It's still going to return the maximum of 74 on the previous. So they didn't break the record in 2012. So understood. The mass function is well understood now, like that. So return the years made out n and the minimum made out n so far. So same thing, just like the previous one. Return the year. So if you return the year, medals end, the medals that end for that year. Then the minimum medals end. So this is the minimum function here. The main function medals. You can put the medals there. Return the year medals and minimum medals end so far. Order by definitely year. Order by year. If you want that, let's check that out. You can see the minimum medals that end this year. You can see 2004 by France. The minimum year was 2022. The minimum year was 21. It is lower than the previous year. The minimum is still 21. So cool, well understood. So let's continue. So this let's reach 50% today.
With the partition and order subclauses, you can change the basis on which window functions operate. Another way to change a window function's behavior is to define a frame. Why would you need a frame? Recall the fetching function last value from the previous chapter. The frame here is range between unbounded preceding and unbounded following. Without the frame, Last value would just return the row's value in the city column, so the city and last city columns would have the same value. That's because, by default, same value. Last value would be unbounded preceding and unbounded following. Without the frame, last value would just return the row's value in the city column, so the
Without a frame, without the frame, last value will return the row's value in the city's column.
city
Right,
and
understand.
last city columns would have the same value. That's because, by default, a frame starts at the beginning of a table or partition and ends at the current row.
So by default, a frame starts at the beginning of a table, which is the first row of the table, and ends at the current row, which is the last
So the
row.
last row last value sees is the current row. The frame clause above extends the frame to the end of the table. How do you define a frame? A frame always starts with range between or rows between. You'll learn the difference between range and rows in the next video, but for now, let's focus on rows. A
Okay.
frame always has a start and a finish. Start and finish can be one of three clauses: preceding, current row, and following.
Mhm.
And preceding defines the frame as either starting or finishing n rows before the current row. Current row is to set the start or finish at the current row, and n following is to set it at n rows after the current row.
I don't know. So preceding the current row, following, preceding the current row. If you select the current row, that will be the next, the row before that, following the current row, unbounded preceding, unbounded following, and current. Okay, I still remember that
Let's see some examples. This
better.
frame starts 3 rows before the current row and ends at the current row, so the frame is 4 rows.
Three rooms, three rows before the current row. Hold up, how did you say that?
Starts 3 rows before the current row and ends at the current row, so the frame is 4 rows.
Three rows preceding the current row. So it's taking four rows. Okay.
This frame starts 1 row before the current row and ends 1 row after the current row, so the frame is 3 rows.
Rows between one preceding and one following. How is it three rows? Give me
Row,
an example.
so the frame is 3 rows. This frame starts 5 rows before the current row and ends 1 row before the current row, so the frame is 5 rows. Let's see how the rows.
Rows between five preceding and one preceding. That's confusing. But
Row,
let's see.
so the frame is 5 rows. Let's see how the frame affects the output of a window function. The source table is the count of medals earned by Russia in these sets of Olympic Games. The max window function is used on the medals column. Without the rows between clause, max would get the maximum medals earned so far for any given year. For the first year, since there's no other value, the max is the first row's value. But for the second row onwards, the max is 66, since no other value is higher. With the rows between clause, since the frame is defined as starting 1 row before the current row and ending at the current row, max only gets the maximum of the values in the previous and current rows.
Hold on. Yeah. Let's understand that. So if you're saying, let's leave that this city away. So we're saying select years, medals, maximum medals over order by year. This is going to get maximum medals understood for each row. But we're using maximum medals over order by year ascending. We now put rows between one preceding and current row. So one preceding the previous row. So one preceding means for this 36, the preceding row, that is the upper row. So there's no row there. So we're going to return 36. But in this case, we're not saying Then it will come back here, one preceding. So since preceding this one is 36, which is lower than 66, going to return 66 there. If you come back here to this row also, one preceding, the maximum is 66 also, but wait a minute. So I'm checking this one. I'm supposed to be checking this medals there. So maximum medals. This one is understandable. From this first maximum medals, the over, whether by year ascending as maximum medals. We're going to return the maximum medals for each row. That's just it. But for the maximum last year, so rows between, so the maximum year is this. So rows between one preceding and current row. One preceding the current row. So this is the current row. One preceding it, there's no record there. We expect 36 back. So if you come to this current row, the next row, so one preceding it is 36, which is not higher than this. So it's going to return 66 also. Now we have 46. This is 47 rather. So one preceding this current row is 47. So this is current row of 47, but one row preceding it, which is 66. So if you compare the two numbers, which one is higher, which one is maximum? We're expecting 66 back here, which is understood. So to come to this 43 here also, one preceding that, so the only one preceding it is 47. If you compare 47 and 43, 47 is higher than 43. This one is going 43 here. We're expecting 47 here. If you come back to this one, compare 47 and 43. One row preceding this 47, which is 43. So 47 is the maximum between 43 and 47. We expect 47 here. I'll use that analogy to nail that knowledge. This one rows preceding the current row. Okay, let's see.
And ending at the current row, max only gets the maximum of the values in the previous and current rows. That's why in 2008 the max is 47 and not 66, since the 2000 Olympics are now out of scope, and max is only looking at the previous and current rows to get the maximum value.
Okay.
And
Yeah.
rows, starting one row before the current, with the rows between clause, since the frame is defined as starting one row before the current row and ending at the current row, max
Okay.
only gets the maximum of the values in the previous and current rows. That's
Exactly.
why in 2008 the max is 47 and not 66.
In 2008, the max is 47. Mm-hmm.
Since the 2000 Olympics are now out of scope, and max is only looking at the previous and current rows to get the maximum value.
Yes. Look at the previous row from here and the current row, compare it together. Okay.
You can also look forward in frames. Here, the frame starts at the current row and ends at the following row, so in the first row, the maximum is 60.
Hold up. Let me take a look at it very well before you explain. You said year medals, maximum medals over, order by year, ascending, rows between, current row, and one following. So you are looking at the current row and one following below it. So it's not one preceding. It's not one preceding. It's Urbanic preceding. Urbanic preceding is looking at the all rows together. But let's see that. So rows between current row. This is the current row of 36. One following the current row. So 36, the next following is 66. We compare 36 and 66. We expect 66 here. Correct? When you look at this current row of 66, so you come again to the current row of 66 and one following the current row, which is 47. Comparing 66 and 47, which was the maximum there, 66, expect 66 there. Comparing this one and this one also, 47 and 43, which is maximum, 47. Come back here, compare this current row and the one following row, 43, 47. So we expect 47 here. We compare this one to any other MC row, which is 0. So now that's really better now.
66, since max is comparing the 1996 and 2000 Olympics. The last row's max is the last row's value.
Yeah. Now I understand it better. Okay.
because there's no following row, so there's no value to compare it to. Frames enable you to change the behavior of a window function by defining what rows the window function takes as input. Practice defining frames in the following exercises.
Yeah, let's practice that. So how many rows does the following frame span? Rows between, three preceding, and two following. That is five frames now. Three preceding, three rows preceding the current row. So three rows up and two rows down. So that is five. Come on. If I'm counting the current row, yes, now look at three rows preceding, three rows the current row. Hold up. The current row is this. Three rows above it. One, two, three. Three rows below it. One, two rows below it. One, two, three. So I have to count the current row to it, making it six. Oh, okay. Hmm. Understood. Let's do some exercise. Oh, we have 50% to this chapter. Let's do a couple of exercises. So frames allows you to restrict the rows passed as input to your Windows function. So a sliding window for you to define the start and finish. Adding a frame to your Windows functions allow you to calculate moving metrics input. Allow you to calculate moving metrics input of which slide from row to row. Return the year, medals end, and the maximum medals end, comparing only the current year and the next year. Return the year, medals end, and the maximum medals end, comparing only the current year and the next year. That's okay. Let's see. So select year, count medals, where country in Denmark, Norway, Finland, Sweden, then Ireland, and medals equal to gold, go by year. Let's run that query there. So you have to return the year, medals end, and the maximum medals end. Let's say select each year's medal. Just select the year here. Control C, Control V. Then the medals. This is the medals. Then get the maximum of the current and next year's medals. Maximum of current and next year's medals. So say maximum max medals. Then you can say maximum medals over comparing the current year and the next year. Order by you also order it by year. So rows between. So comparing only the current year and the next year. Compare only the current year and next year. Rows between that will be one preceding, definitely one preceding. Okay, compare only the current year and next year. That will be one following and current row. Current row. So It said comparing only the current year and the next year. So one following and current service. So that is it. It can also be current row and one following. Let me run that first. It can be also be on the flip side. It said rules between one following and current row. But I'm interpreting it, comparing only the current year and next year. So I can say, I can also say current row, current row, and one following. Aha. So if I'm saying between rules between current row and one following, we compare the current row. So this is the order by year. So this is the current row for this year. So there's nothing to compare it with, which is this one. So I'll compare this one with this one. So the same thing. The maximum there is still one, which is one. Yeah. So if you check 1900, the middle one is one. So if you compare it to next year, which is 77, you are expecting 77 to be returned there. Then the current row is 77, this is 1908. Compare it to the next year's medal, which is 141. So expect the maximum year between these numbers to be 141 or something like that. So let's submit that and see. And boom, we got that. That's cool. Let's do last exercise there. So return the outlet medals end and the maximum medals end. Comparing only the last two current athletes. Only the last two and the current athletes. That should be uh, two preceding and current row. Okay, definitely two preceding and current. So let's give it a shot. So if I run this city here, Chinese medals, country is China, and the medal they've won is gold medal from the year 2000 upwards. I run this code here. Want to compare the last two athletes, comparing only the last two athletes and the current. So one, two, this is an athlete, then two, last two, no record there. Here an athlete, last two, only one here. So this is an athlete, last two is this one here. So I come back here, select the athlete, select athletes, the medals the athlete has won, then get the maximum of the last two and current two medals. Maximum be max medals over order by ordering by athletes. We can order it by athletes. Order by athletes. Now rows between it says return the athlete medals in and the maximum medals in. Comparing only the last two. That should be two preceding, two preceding. Did I get the spelling of preceding very well? two preceding, and the current row. Last one, the current affiliate, and current row. Expect that, and boom. I think we're on track. If you check the last, this crowd yearly, there's no last two rows, the upper two rows. It's only one day. Cow yearly also, last two, no. Look at this cow, cowly. Last two is only meta is one. The last two is also one with only one year. Let's check that. Double check. This cow yarn. Last two is one. So let me scroll down a little bit and compare from this current one here. Let's compare this guy here. Chain. The last two is his own medal is one, but his last two is 4 and 1. So expecting a 4 here. Look at this guy also. His own medal is 1. His last compared to his last two, expecting 4. Let's compare this two here. Is this chain Yang King? So his own medal is 2, but the last two is 1 1. So his own medal is higher than his maximum is 2. When you compare this one now, his medal is 3, his last two is 2 and 1, so expect 3 here. So that is pretty correct. Yeah, they are correct. So rows between two preceding now coming to, and boom, moving averages and total. We are 60% to this chapter. I would love to end the live stream here and here. Alright, so thanks for staying to the end of the live stream. So if you enjoy what I'm doing, kindly support the channel by subscribing to the channel and giving this video a thumbs up. Also, use the link in the YouTube description to purchase FCM if you really want to become a top rated plus or top 1% freelancer in the world and start your own freelancing career also, just like me, and work from home and anywhere you are in the world based on your own schedule and time. So thanks for staying to the end of the live. Don't forget to subscribe to the channel. Support the channel also by liking this video and hitting the subscribe button and put on the notification bell to be the first to know when I drop new content, when I go live stream or drop new content on Excel, Power BI, and other future videos. Thanks for staying to the end, and I'll see you tomorrow. And peace out.